us for our session, Jamf Protect API 101. And I'm really looking forward to introducing our host. But before I do, I just want to call out, I'll also be running around and doing Q&A at the end. So any questions that come up through here, hold them off until the Q&A section, and then hands in the air then. I'll run and get you the mic, want to make sure everyone can hear the question. So without further ado, I would love to introduce Matteo.
Hello, good afternoon and welcome. This is Jamf Protect API 101. My name is Matteo and I'm a product specialist here at Jamf. So let's get right into and we're going to have a look at the agenda for today. So we're going to start with a little bit of an introduction of GraphQL. So when we're talking Jamf Protect API, that's based on GraphQL. We're going to then move on and actually see a little bit of the differences between GraphQL and REST. So probably most of us are more familiar with REST APIs like the Jamf Pro one. And we're going to see how the Protect one is different because it's based on GraphQL. And then we're going to just get started with the Jamf Protect API. We're going to see how we can set up from the scratch and just dig into. And then I have a couple of workflows, ideas, suggestions on actually real use case scenarios for Jamf Protect. So moving on. Introduction to GraphQL. This is going to be very brief and high-level introduction. GraphQL, how we can define that, a query language for APIs. So when you hear query, you might think of database like MySQL languages. Well, that's pretty close because GraphQL is actually structuring the data. So that's why it's GraphQL, query language. And it was originally developed by Facebook in 2012, and it was then open sourced subsequently. The structure of the data is declarative data fetching. We're gonna see more about that when we actually see the differences with REST. And the very peculiar thing of GraphQL is that the server exposes a single endpoint. So with REST, we probably are all familiar, there's different endpoints for different data sources. GraphQL is a single endpoint. So let's start actually getting into and seeing the differences between GraphQL and REST. For this one, I'm gonna just use a very basic example. So let's say that I wanna have a little widget on my blog displaying my blog's name, the last 3 posts, and the recent follower. So I need to build with the API a structure to actually pull this data from my blog and actually display that as a widget. We're gonna just use this as an example, and we're gonna see that with REST and GraphQL. So with GraphQL, what we're doing is an actual post. So GraphQL is only, we are only posting data. We don't do get, read, and we actually post payload to actually get information from the API. So for example, if we want to get my blog's name, for example, we're posting this query with the name, and then we're going to actually get the posts. So we'll require the post and the title of those posts. And then if we want, for example, the follower, I just want the last 3 followers on my blog, I can actually request that within the query. The actual response that I'm going to get is a standard HTTP response, and as you can see, the format is very, very clear, it's very, very defined, and it's only the actual data that I requested. So we're getting the data that we specifically requested. We don't get any redundant data. When we talk GraphQL, anything that we're talking about reading data, that's called queries. Anything that instead is creating, updating, or deleting data, those are called mutations. So this is the pretty big difference between REST. We don't have, we only have 2 operations: queries to read data, any kind of data manipulation, be that create, update, or read, that's going to be a mutation. And again, all of those, both queries and mutation, they go to the exact same endpoint. So for example, in your Jamf Protect tenant, you will have example or your tenant name, and you will have .protect.jamfcloud.com and /GraphQL. This is where all your queries are going to be targeted to. So if we now go back to the actual same example as we did before on how can we accomplish that with GraphQL, let's see how we would have done that with REST API. Well, with a REST API, there will be likely 3 endpoints. Again, this is like an example, so it's not like real data, it's just to give you an idea of the differences. So we'll need to request data from a users/ID to actually get the name of my blog. And then we'll have to get, again, users ID, and we'll have a post endpoint to actually get the post. And then we will have a follower endpoint to actually request the follower. So if we actually break this down, it's gonna be, clicker a little bit sleepy. So we're gonna have to do a GET request on the user's ID, and we get a response. The response will not only contain the data that I need, so it won't contain only the name, it will contain additional data that it depends on the developer of the application, but there will be additional data in there. And the same goes when we're actually going to get the follower. We're gonna do like a GET request, users, ID, posts, and we're gonna get the response back that contains actually the posts, so the titles, but it contains other stuff as well, like the content and the comments and things like that. And again, the same is gonna be for the users, for the followers, sorry. When you wanna get like the follower, you don't get only the follower data, you get like the name, and then you're gonna get like maybe an address or a birthday or something. So this is like kind of like to give the idea of like the main differences between REST and GraphQL. GraphQL really enables you for, again, as we see before, like the definitions like declarative data fetching. So it enables us to be very, very specific on the data that we actually want from the endpoint. And what we can actually do is, instead of like getting information from an endpoint and then parsing it out, like I think we're all familiar when we're like scripting with a REST API, we have to parse out the actual data that we need. So we always get like an excess of data that we don't need and we have to parse out. With GraphQL, we are able to actually specify what information we need and get just those. So we are only gonna get back information that we requested. We're not gonna get back any kind of information that we haven't requested. And this, of course, is like good because we don't have redundant data to parsing. We don't have, it's gonna help for like server performances because we don't get like that much data that we don't need. So moving on, we're gonna like see how we can get started with the Jamf Protect API, how we get our hands dirty with. What you see on the screen, I think everyone that's here is pretty familiar with, just our dashboard of Jamf Protect. And to actually get started, you will go into the administrative and API clients. Just go there, you create an API client, you give it a name. Yes, that's a real token, but it's already invalidated, so yeah, screenshotting it doesn't work. And one important thing, when you do that, it's gonna actually tell you, hey, this will not be shown again. Yes, this is actually a one-time only, so you will get the password for the API client only when you create it. And if you lose it, you'll have to go back and create a new one. So make a note the first time you create it. So we say like, oh, there's only one endpoint. Well, technically 2, because we need actually to get a token, because to authenticate to our API, we actually need a token. There's no basic auth, there's no username password authentication enabled. So there is a dedicated endpoint only for the token. So we're gonna have to send those token requests to this endpoint. And then everything, as you said, like everything else is gonna get to the /GraphQL. So we're gonna go to the /token to request the token with our API client and password, and then all the requests are gonna go to the /GraphQL. How do we request a token? Just simple example in Bash. We're just posting a payload with our URL, and the data is gonna be simple, like the client ID and the password. In this example, there's JQ for parsing, because yeah, you're gonna get back a JSON file, so you will need to parse that. When dealing with the API, specifically with the Protect one, you're gonna deal with like a lot of JSONs, so I usually recommend to use Python because it's just more suited to like parse large amount of data in JSON. So in Python, that will be pretty much the same. We're gonna have our token URL, and then we're gonna have a payload which is basically just the client ID and the password, and we're just gonna post that as a request. So this is all great, but we don't want to get like started immediately with scripting and stuff. And so there's like an easier approach. Altair GraphQL client, it's an application available for macOS, and it really helps you get started with like a nice UI. So it's easy to interact with Protect. I really like it because it also offers some kind of like built-in debugging. So it's really helpful, like when you have an error on your queries. It tries to do like some kind of like predictive behavior and try to say like, hey, did you mean that or something else? So it tries to autocorrect in case of mistakes. And the most important thing, at least for me, is that the GraphQL schema of Protect is actually built in there. So you can actually go and dig out the entire schema, which we're going to see in a second. This is a QR code with the documentation on our website to get started and to actually download. I hope the QR works. If it doesn't, just let me know at the end, and I'll get you the links. So once you download Altair, you go in there and you create what's called like an environment. This is going to be basically like your baseline, and you simply provide your API client secret and password. Again, very simple structure. So when we done have configured that, Altair will go to the API endpoint, the token one, request a token, and we're all set. So where do we start? In the top right of the application, we'll have a docs. So we can actually go there, and for example, I want to look for a query as an example. So we actually can go within the queries, and within the queries, there is a very useful button that is add a query. So for example, in here, we're using the list computer endpoint. It's going to actually return information for the computers. Like you can imagine that as like an inventory of Jamf Pro. So if you click on that add query, I love this. GraphQL actually pre-build the entire query that you are going to have to post then. So kind of like pre-populate everything, it's nicely formatted, and we're ready to run, right? We do have our token, we do have our query, we hit run. And yep, we got some errors. Well, let's dig into it. So if we have a look at the error, it's actually saying like something not really nice. Validation of errors, subselection required for the type plan. Just a little bit complex. Let's just go back to the UI. And when we go back there, we actually see there's like, since those fields, they have like red wording. And if you hover on, Altair tries to be a little bit more verbose or humanly understandable and say, hey, your that field, the plan that you're requesting, must have a unique subfield. What does it mean? So if we hop back in the documentation and we actually go and see what's for the plan, we can actually see that the plan has multiple subfields. So this is like the very thing that is particular and specific to GraphQL. When you're requesting a field that does have multiple subfields, by default, you have to specify each subfield or put like curly brackets to say, I want them all. But otherwise, you will get an error because, again, because GraphQL is like so specific and particular, it wants you to be specific and particular about what data you're requesting. And if you're not, it's just going to throw an error. So in this case, for example, if you're only interested, for example, my plan, I just want to know the ID, the name, and the last time that it was updated. In my query, I will build plan, and then within curly brackets, ID, name, and updated. If I want all the information from the plan, I can just put curly brackets and 3 dots, and I'm going to request all the subfields. But otherwise, you can pretty much customize it as you wish. So, a couple of tips on how to integrate with the API. Pagination, really important. So the maximum amount of records that you're going to get like in per request. So if you don't specify that, we set it by default to 100, and the maximum size that is available is 200. What does mean is like if you have 100 computers in your Jamf Pro instance and in your Jamf Protect instance, and you run a query to pull them, it's going to work. If you have 101, it's not going to work because you will need to request the page after. So what this means. So you have to specify in the request the actual pagination that you want, so the page size, and you can do that in two ways. You can either hard code, let's say, the maximum page size. So you can do like, this is just a query, endpoint, list computer, input, and we just do like page size 200, so we can request the maximum size available. Or, and this is something I kind of like, what you can do is you can take the page size as a variable. So every time that you're going to make a request, you will get the result, and then the next result is going to be after requesting the second page, and so on, and so on, and so on for all the devices that you have. So you don't have to think about like pagination, and you don't have to think about like how do I make this scalable. You just request on each query the next page, and it will just iterate through the amount of data that you have to query. We were talking about rate limiting. There's no rate limiting within our API, so you can send as many queries as you want. Just please be careful of our servers. The token lifetime is actually 24 hours. So when you go to the /token endpoint and you request a token, that token is valid for 24 hours, and you're free to actually reuse those tokens. So you can, if you're using them, you can just request a token, store it somewhere safe, and then reuse it as much as you want as far as it's valid, so within the 24 hours. So moving on, as I said, like we're gonna see like now a couple of like real life example of like, hey, what problems does the API solve? Why we want to even use that? So I'm gonna start with actually like a question that one might have is like, is the threat prevention database up to date on our Macs? So the threat prevention database is the actual database of the known malware and bad stuff hashes that we have on the device, and it needs to be updated on the device, of course. So if your device doesn't update this database, well, that's a problem. So how can we make sure that we can check if our devices are actually updating the threat prevention database? So we're going to start with actually checking the threat prevent version per device. So we can build a query like this, and we can target again the list computer endpoints, and we're actually requesting the serial number, the last time of the check-in of this device, signature version, that is actually the threat prevention version, and we're going to request the version, and that's the actual version of the Jamf Protect agent. And the response that we're going to get is something like this. So we see the signature in this case, like this was taken like a couple of months ago, so it's not up to date. But you see like those two devices, they have version 4972. And I wanted to like show something that the threat prevention database is updated independently from the agent. In this case, you can see one agent version is like on 3.3 and the other one is on 3.2. So the threat prevention database gets updated independently from the agent. What we can then check now that we have the threat prevention database that is on our devices, we can actually check the actual Jamf Protect database. So what's the version there? So we can actually compare them. And we will get like a list of all the IDs of the threat prevention databases and the last time it was updated. So we can, if we like just zoom in, we can grab the ID and we can see the last time it was created. So in this case, what we can do, we then have the IDs that we have on the devices. We have the ID that is actually the latest one in the Jamf Protect database, and then we can actually check and make sure like, are all devices updating the threat prevention database? And if not, well, we should have a look at that. So another example, and this is like customer stories that we've heard and we came up with, is like one might want to know, like when a new analytic is added to the Protect tenant. As you know, we at Jamf, we keep adding new analytics, but we don't turn them on by default. And we actually don't have like a really good way to notify for them. Or you might have like a colleague that goes and create an analytic and within a team, everyone, should share what's going on. But like, sometimes one can forget, and you're like, just want to make sure that every time someone creates an analytic, we're all on the same page and we all know. And yeah, having something like in Slack, for example, will be good. So how do we make this work? We can actually write a query like this that is going to actually list to the list analytic data set, and we can request, for example, like the hash, the name, when it was created, updated, the description, so we actually know, what's that analytic. That Jamf field is going to tell you like if the analytic was created by Jamf or it's a custom one that someone actually manually created, and we can pull the severity and the UUID. Then you can actually take this analytic and, for example, run it on a Lambda. So you run the first time, and you're going to actually get like a set of all the analytics, and you're going to get like a JSON file. And you can take this JSON file and store it on an S3 bucket, for example. And then after 15 minutes, 60 minutes, or 6 hours, or whatever you think suits your needs, you just rerun the exact same, and you're going to get like a second JSON. So now by comparing those two JSON files, we can actually know if a new analytic has been added. And if it has been, what we can do is we can actually take that analytic, those details, and just post them to Slack using the Slack public API. And what we're going to end up is a message like this. So we're going to get like a nice Slack message with the name of the analytics, species of this file creation, the owner, in this case is Jamf, or it will say custom if it's like a custom analytic build, the description, and then we can actually get the severity, when it was created, and when it was last modified. And then that hyperlink you see there, it's going to actually take you to your protect tenant, and that's simply constructed using the UUID of the analytic. The script to actually make this magic happen is available on our GitHub repo, that is on the QR code over there. So a little bit of recap of this session. We have seen a little bit like a very brief introduction on GraphQL. We have seen what are the main differences between GraphQL and REST. We've seen like how do we get started, again, either manually or with the Altair client. And then we have like a couple of workflows and idea, something maybe you like can take home and have a thoughts on. Oh, yeah. One more thing. Just want to give a shout out to the Mac Admins Foundation. They just constituted as a non-profit organization in April this year. If you're familiar with them, I saw a lot of people with the t-shirt. Good. If you're not, macadmins.org or scan the QR code and go check out the project. And please, if you can, consider supporting them. And that said, thanks everyone for your time, and we'll open up for some Q&A, if any.
You can feel free to put your hand in the air if you do have a question. I'll come right on over to you.
So you're implementing integration with, like, say, Splunk, for example. Is it using the Graph API?
So no, in the sense that if you're sending alerts or log stream to Splunk, no, that doesn't use GraphQL. That's like the device itself that just sends the information to Splunk directly, so it doesn't go via the API. It uses the same logic as the Splunk load forwarder, so that doesn't use that. But if you have Splunk and you want to actually build some stuff with the API, you can do that. Like the same that I've shown here, running like on a Lambda, you can do that like on Splunk, and you can use webhooks as well. So yeah, it can be used with Splunk. It just takes a little bit more work.
Yeah, cool. Thank you.
that's a wrap for today. Thank you for showing up and enjoy the party later.